Okay, let's have a look at the equations of motion, sometimes called the SUVAT equations or formula, or the kinematics formula. So you may have come across these at GCSE. Well, this one we've seen already. You might have seen this one at GCSE possibly, but generally speaking at Physics A level, this is fairly new for most students. So there's these four formula. There's actually a fifth one which we never really use, but these are the four standard ones. You are given these in the formula booklet, so you're not expected to remember them, but you should have used them so much. You should be so familiar with these formula that you shouldn't have to look through the formula booklet unless you have a total memory blank in the exam. So these are all for constant acceleration. This is really important. So if we have constant velocity, then we would not use these. They wouldn't be relevant because acceleration would be zero. So very importantly, if we do have constant acceleration, you cannot use v equals s over t. And this is a very common mistake that a lot of students make, is we have an accelerating situation, an object is accelerating, and they calculate v equals s over t. So that's not going to work. In terms of where they come from, well, the v equals u plus at, that comes from the definition of acceleration, a equals v minus u over t. And in fact, this one here, you should see a similarity to v equals s over t. If you make s the subject, s equals v times t. But rather than one constant velocity, we're actually finding the average velocity, u plus v over 2. So these two here, we can actually work out from definitions. The other two, we cannot work these out from a definition. We have to derive these algebraically, and we'll do that later on in the series. And very often, depending on your exam board, you might be expected to do that in the exam. But to start off with, the most important thing is, what do all the symbols mean? So I think A and T are pretty obvious. Remember, S does not mean speed, and S does not mean seconds. S is displacement, so that's very important. And as we've seen previously, V and U, so we have final velocity and the initial velocity. So I'm going to take you through a few worked examples of how to use these formula to solve simple problems. So the first worked example, this is a nice simple one. We have a plane moves in a straight line with uniform acceleration. So that word uniform is very important. That means constant, 15 meters per second squared, which is a very large acceleration. The initial velocity is 0. Find the velocity after 4 seconds. Right, so how do we approach this? We have four formula. So there's always a standard approach. We will, well, hopefully be given 3 of the values. We're told the initial velocity is 0, so we're told this value here. We're told the acceleration is 15, and we're told the time is 4. So normally, and hopefully, we will be given 3 values. And we're trying to find a 4th value. It says find its velocity. Now, it doesn't say find the final velocity, but we know it must be the final velocity because 4 seconds have passed. So this is our start point, U, A, T, and V. We need to find one of these formula which has all 4 of these letters. And hopefully we can see that it's this first one here, V equals U plus AT. And in fact, we don't have to rearrange this because V is already the subject. And in fact, U is 0, so that makes it even simpler. So it's a simple substitution, 0 plus 15 times 4, we get 60 meters per second. So that's a nice, easy question. Now, a few things here. You're not expected in the exam to write out these first 2 stages, but you would be expected to write out the formula and show the substitution, and then have the correct answer with the correct units. And this is really important. Some students think if you see how to do this, oh, it's just 15 times by 4, then you skip out a stage. You don't show all the working out, and that's really bad practice in the exam. So you really need to get into the habit of showing all your working and laying out your answer, something like as shown here. Let's have a look at another example. So we have a car moving in a straight line. That's nice. Constant acceleration of 2 meters per second squared. In this case, we're told the final velocity is 30 and it travels for 15 seconds. Right, so part A, find the car's initial velocity. So once again, we can write down the 3 values that we're given. We're given the acceleration is 2. In this case, we're told the final velocity is 30, and we're told the time is 15. and we're trying to find the initial velocity. So we're trying to find u. So once again, we're going to be using the same formula, v, u, a, and t. That's the only one of these four which has got the four values that we're interested in. However, in this case, we're trying to find u, not v. So we need to rearrange to make u the subject. U is equal to v minus at. And then we can substitute the values. 30, take away 2 times 15, and we get 0. So it turns out in this case that the initial velocity was 0. Once again, even if with these simple numbers, if you could just work that out in your head, don't just write down the answer 0. You need to get into the habit of showing all your working. And I really would recommend rearranging the formula before you substitute. If you substitute and then rearrange, you're more likely to make a mistake. Right, part B says find the distance traveled. Okay, well, distance, displacement, in this case, would be the same thing. And now we actually have a choice because we're trying to find S, displacement. We've actually got 3 of these formulae we could use. We have S, S, and S in these 3. So any one of these 3 would work. That would be fine. And sometimes students find that a little bit confusing because they don't know which one to use. Well, it's going to be the same answer. And you could try all 3 if you want to, just to make sure you get the same value each time. But I've decided to use S equals ut plus half at squared. In this case, we found u is 0 already. So this is quite useful. U times t, 0 times t is going to be 0. And this we will find later on is a very, very useful simplification. Very often, ut we can just remove from the formula. So this actually simplifies it to half at squared. So half multiplied by a, we're given a, I think, half times by 2 times by 15 squared, and we should get the answer of 225. Right, the final worked example is shown on the screen. So we have a constant deceleration of magnitude 2. So a lot of this is terminology. Magnitude just means the size. Deceleration, that's really important. So the deceleration means it's going to be negative 2. So when we're writing out the value here, a is minus 2. It says the speed at the bottom of the hill is 10. Okay, that's the initial velocity. How far will he travel? We're trying to find S, the displacement, before he comes to rest. That's another common phrase. So a lot of this is to do with language. Comes to rest means the final velocity is 0. So in this case, we know A, V, and U. We're trying to find S. So we need to look at which of these 4 has A, V, U, and S. And we should be able to notice that it's V squared, U squared, 2AS. In this case, we're going to have to rearrange because we're trying to find S. So like I said before, I would rearrange this before you substitute. I think you're less likely to make a mistake if you do that. So make S the subject. S equals V squared minus U squared over 2A. And then we can substitute. And this is really important here that we get the V and the U the right way round. So U is 0. So we have minus 10 squared. We have minus 100 on the top of the fraction. But then we're dividing by a negative number on the bottom. We're going to divide by minus 4. So we end up with positive 25. So in this case, getting a value of positive 25 makes sense because we're moving forward and decelerating to 0. You could get a value of negative displacement. That's absolutely fine. It wouldn't really make sense in this case because the cyclist would have had to roll back beyond their start position, which is unlikely on a bike, but it is possible in another question. So once again, write out the formula, rearrange, substitute the values, write the answer with the correct units. So these 3 questions that I've picked are relatively straightforward. You need to be really, really confident with increasingly more complex questions. And I recommend you practice as many of these questions as possible.